द फर्स्ट क्वेश्चन आपने इस इनमें जो है वो क्रिटिकली अंडरस्टैंड करना है सम ऑफ द पार्ट्स ऑफ द क्वेश्चंस. We have a long chain alkanes that can be broken down into shorter chain alkanes and gaseous alkenes. This part comes from your organic chemistry, which you are already familiar. So that happens जब कभी आप longer chain alkanes को smaller chain molecules में break down कर सकते हैं. Students, if you have any queries at any part, please leave your message in the chat box. Okay, so vapor from a long chain alkane is passed over a very hot catalyst, and the gases formed are collected over the water. The apparatus used is shown. So we have this complete setup, and we have to understand what is happening here. The long chain alkane on mineral wool that is placed in this test tube over here, and then this is the aluminum oxide catalyst, a delivery tube, and this goes into this trough containing the water. Trough को आप water bath समझ लें. This is a water bath. Okay. Now first question says name the item of the apparatus labeled A in figure 1.1. So what is this thing? This large size of the container. You can call it as water bath. This is water bath, or you can also call it as trough. So this is about this one. Then second part, the catalyst is small pieces of aluminum oxide. Explain why several pieces of aluminum oxide speed up the reaction more than the one with large pieces of aluminum oxide. So we remember from the chapter of reaction kinetics that catalyst works whenever they have larger surface area. Yeah, in other words, the rate of the reaction can be increased by increasing the surface area. And large pieces have smaller surface area. Surface area is smaller for the larger pieces. Surface area is smaller. And for smaller pieces, the surface area is greater. It is greater. So we will say to increase the surface area. I hope it's clear to everyone. Then our next part, C part 1. Name the item of the apparatus that can be used to heat the long chain alkane and the catalyst. So how can we provide heat to the long chain alkane over here? What do you think? How can we provide the heat? Bunsen burner. That is right. क्योंकि ये एक टेस्ट ट्यूब है, so to reach to the level of the test tube, we do need a Bunsen burner. That will be something like this one with a stand, and then it has the flame coming out from the top of it. So that can be used here to provide heat to the alkane. Basically, alkane is somewhere here, but this whole thing can give the heat. So yes, we will use a Bunsen burner. And then next part, add two arrows to figure 1.1 to show where the apparatus should be heated. You need to put arrows here to locate the points where you can provide heat. Two arrows. So according to the question statement, it says that vapor from a long chain alkane is passed over a very hot catalyst. अब हमने लॉन्ग चेन्स को भी हमने हीट करना है और साथ में हमने कैटलिस्ट को भी हीट करना है. बोथ ऑफ देम मस्ट बी हीटेड, alkanes भी and the catalyst भी. So the arrows that must be represented here, we need to put one arrow just below the cotton wool, the wool containing the long chain alkane, one over here, and another arrow which should be over here. So this is how we can get the correct arrows. D part. The gas collected is tested using the aqueous bromine. Alkenes turn aqueous bromine from orange to colorless. When the first few bubbles of gas collected are tested, the aqueous bromine does not change color. Explain why the aqueous bromine does not change color. So the heating of the uh, alkane molecule, हमें ये पता है it is saying कि the long chain alkanes, I will write in a short form, long chain alkanes, when go through the heat, it converts into short chain alkanes plus alkenes. This is what we understand about the. Uh, can someone tell me which kind of reaction is this? What kind of reaction is this? Very good. It is cracking. So the cracking basically produces the alkenes and during the reaction, and the gas collected is tested using the bromine. This is the gas which is alkene. We get small size alkene during the cracking, and this can react with the bromine. And we remember this is a bromine water test. I'm also revising you the organic chemistry during the question practice. So bromine water test is done by the reaction with alkene, bromine plus alkene, bromine water plus alkene. And bromine water is presented as Br2 with the aqueous symbol plus alkene. And there is the formation of the bromoalkane as a product. Bromoalkane. But the thing is here, the first few bubbles of the gas collected are tested. The bubbles do not change the color, which means that gas is not the alkene. It's not alkene. It is any other gas. We need to understand which gas could it be. So if we look at here the diagram, we should remember that from the long chain alkanes that is made up of hydrocarbons, they are hydrocarbons. We can also get H2 as a gas. Some amount of the H2 gas can also be produced during the cracking of the hydrocarbons. So it could be this gas that is being coming out. So we would say that the uh, that is it is hydrogen gas, maybe it could be hydrogen gas, H2 gas, or we can also say it is air. It could be air, because if you are not getting hydrogen gas, but at least the air entrapped inside the test tube is coming out into the delivery tube, the air which is entrapped in the test tube. So this is also not giving you the positive test with the bromine water. I hope it's clear to everyone. Then next part, as soon as the experiment is over and the heating is stopped, what happens if the delivery tube is not removed from the water as soon as the heating is stopped? Okay. So we know that the reaction is being done by the heating of the wool, by the heating of the catalyst, and the gaseous alkenes are being collected over here. Once they are all completely used up, there will be no more gas being moving away or moving inside this delivery tube, no more gas. As the gas is no more moving and already the gas has been collected over here, you can think of a situation that this is how the gas is traveling and moving in the inverted measuring cylinder. But once this stops, it does not happen. What will happen? This water can move in the backward direction. Are you getting the point?
Yes, sir.
The water will travel like this in the opposite direction because of its own force. The gas that was previously being produced from the reaction between the catalyst and the alkane, it is no more there. So nothing is going to stop or resist the water from entering into the delivery tube. So in that situation, we would say the water will enter, it will be pumped, it will be entered into the delivery tube, it goes into the delivery tube, and what if it just reaches inside the test tube? We remember it was previously heated by the Bunsen burner to make the reaction feasible, and this is hot test tube. If it comes in contact with the cold water, this is the cold water which is entering into the test tube. When they unite together, they will break the glass of the test tube. The glass of the test tube will be broken by the combination of the cold water and the already heated test tube. So this will crack. What we write here, the water goes in, goes into the test tube, and it breaks it, and it breaks it. So this will be the situation. Now, the next question, if there is any question from anyone, please let me know in the chat box or by raising the hand, whatever you have, or speak in a microphone.
No questions.
All right. Now, question number 2. A student investigates a solubility of ammonium chloride in water at different temperatures. The student does 5 experiments using the following instructions. Experiment number 1 is fill a burette with the distilled water. Run some of the water out of the burette so that the level of the water is on the burette scale. I hope you remember the picture of the burette. It's a long column of the glass, and at one end there is a tap. So that tap can be used to open to let go the liquid inside the burette. Use a burette to add 8 cm cube distilled water to a 5.52 gram sample of ammonium chloride in a boiling tube. We have the ammonium chloride present in this test tube. Clamp the boiling tube at an angle as shown in figure. So it is almost 45-degree angle. Gently heat the bottom of the boiling tube while stirring the contents with a thermometer. So heat the solid of the ammonium chloride and also check the temperature using the thermometer. Stop heating as soon as all the solid has dissolved. So while you will be heating the solid compound, uh, it will start dissolving into the water. Continuously stir the solution with the thermometer while it cools. So you can think that there is also a test tube present in this. There is a thermometer, the thermometer inserted into the test tube, and you have to keep stirring the test tube. So you have to keep stirring the thermometer while you will also be noting the temperature. So that stirring is done using the thermometer. Measure the temperature solution as soon as the solution becomes cloudy and a white sauce and a solid start to form. So reaction is being done between the ammonium chloride. Can someone tell me the formula of the ammonium chloride? I will take question from Ishal. Ishal, do you know the formula of the ammonium chloride? Yes, good. NH4Cl. This is NH4Cl. Okay, so yes, NH4Cl is being dissolved. Use the burette to add 0. Now comes the second experiment. Use the burette to add 0.5 cm cube of the distilled water to the mixture in the boiling tube from the previous experiment. Uh, we already have distilled water present in the burette. Clamp the boiling tube as shown in figure 2.1. Gently heat the bottom of the boiling tube while stirring the content with the thermometer. Stop heating as soon as the solid has dissolved. Now, basically, you have added some more amount of the distilled water, and again, you heat the boiling tube to dissolve the ammonium chloride, and stop heating once all the solid has been dissolved. Continuously stir the solution with the thermometer while it cools. Measure the temperature of the solution as soon as solution becomes cloudy and a solid start form. So, what is happening? While heating, it is dissolving. During heating, it dissolves ammonium chloride. And when it cools, it becomes solid and also white in color. it turns white because of the solid formation. And you have to note that measure. And you have to note that temperature. Experiment 3, repeat experiment 2, experiment 4, repeat experiment 2, experiment 5, repeat experiment 2. So you have to keep doing this by adding more and more amount of the 0.5 cm cube of the distilled water. You have to keep adding more and more water, and you keep noting the temperature of the moment when it turns cloudy. A. Use the information, the description of the experiment and the thermometer diagrams to complete the table. Okay. Mass of ammonium chloride, you have to use the information in the description of the experiments and the thermometer diagrams. So a mass of the ammonium chloride that is going to be dissolved, what it would be, and total volume of the water that you will keep adding. So how much mass of the sodium chloride, how much mass of the ammonium chloride was added? It was mentioned in the statement. So this is the mass, 5.25 gram. 5.25 gram of the ammonium chloride was dissolved. So you will have this value in all of the boxes here. In second column, 5.25 here, 5.25, and for everyone, for all the boxes. And then second column says total volume of the water added. Okay, so if you go back to experiment number 1, it says 8 cm cube of the distilled water was added. That is already mentioned in the question. And in the second experiment, how much is the amount of the water added? You know that in experiment number 2, we added 0.5 cm3 as an extra amount. This is the extra volume of the water added into the experiment number 2. So add that value here, it will become 8.5. And keep doing this. Add 0.5 cm cubes additionally in all the subsequent experiments. So this will become 9.0. Next one is 9.5. Next one is 10.0. Okay, now comes this part. You have to note the temperature from this test tube. Thermometer diagram when a solid starts to form, temperature when a solid starts to form. So this is the diagram and you have to tell the value. So thermometer is your daily based equipment which you have been using in your homes as well for different purposes. So which value do you see here? This is 75, 76, 77, 78, 79, and 80. So this value is in between 78 and 79. So the value you will write here will be 78.5. I hope it's clear to everyone. Then this thermometer. Sarah, what do you think? What shall be the value for this thermometer? Yes, Sarah. 68. Okay. 68.5. Now look carefully. This one is 65. This is 66. And this one is 67. This is 67. 68.5 will be over here. This one is 68.5. All right. So your value will be 67. You do not need to write the degree sign here. You do not need to write this value because it's already there in the title. It's already there. So you don't need to write degree centigrade. Okay, then next is this one. It is clearly seen 60. Then next one. So it is in between 53 and 54. This is 53, this is 54. So it will be 53.5. And next one, 49. Okay, so let's see the order. We can see when there was this much volume of the water, we had 78.5. And as soon as we started adding the water more, the temperature is dropping. The temperature is falling by adding more amount of the distilled water. Complete a suitable scale on the y-axis on figure 2.2 and plot your result from experiment 1 to 5 on figure. Draw a line of best fit through your points. So students, you must be familiar that in your ATP you will be given these type of the graph papers. That means you must have the printout of the ATP workbook with you every time. So those who have the printout, they may start plotting the points on the graph paper and see for yourself what kind of line are you getting. You have to draw a line of best fit. I hope your physics teacher would have guided you how to draw a line of the best fit. So I will be plotting the points on the graph and then plot a line through those points. Starting from the first value, on the y-axis, we have the temperature and x-axis is the total volume. So temperature for the first amount was at 8 degree, at 8 cm cube, the temperature was 78.5 degree. 78.5, then 67, then 60. So let's see where it comes. If this is 30, this would be 40. We have to plot the values. 40, 50, 60, 70, and this one is 80. Okay, 78.5 at 8 cm cube. So we will have 75, 76, 77, and 78. So this is this one. So plot a point over here. Just put a cross, a small cross here, like this. So this is my first point. The second temperature was at the value of 8.5 cm cube, 8.5 cm cube with a value of 67 and then 60. 67 will be here and 65, 66, 67, this one. And the volume is 8.5. Then next value is at 60, add 9, this one. After this we have 53.5 and 49. 53.5. So this is 55, 54, 53. So this will be the central point, 53.5, and then The last value is 49. So 49 will be at 10 cm cube at 9.5, and this will 10, 49, this one. So at 10 cm cube, it is 49. Now, what kind of curve do you see, or how would you draw a line of best fit here? How would you draw a line of best fit here? It will go straight. I will try my best to do with my hand like this. Some point will be below, some point will be above to make it a balanced line. Extrapolate extrapolate the line on your graph and reduce the temperature when a solid starts to form. Okay. Extrapolate the line on your graph and reduce the temperature when a solid starts to form when a total volume of 10.5 cm3 water is used. 10.5. Okay. Now we ended our graph over here. We have to extrapolate that line. That means we have to keep doing this for an extended time, extended line length somewhere here. Now at 10.5 cm cube of the water, the temperature is over here. Now let me check where does it come. It goes over here. This one. So this value is roughly at 43.5. I might be wrong because the reason I'm doing with my hands. So I could be wrong in this case. So for my case, I will be 43.5 degree. Is it clear to everyone? How are we doing this? So the temperature has been noted for this case. Then the D part. Yes, Ishal.
Sir, I didn't really understand C part.
In C part, you are supposed to find the temperature of the solid formation when 10.5 cm cube of water was used by extrapolating. What is extrapolating? If let's suppose the line stops somewhere here, you have to extend that line. This is called extrapolate. This is called extrapolate. This dotted line is called extrapolating, which is just to say you have to extend something. Either although it's not there, but you have to do by yourself. So we remember from this chart, we remember from this graph that our line stop, it should have stopped at 10.0 centimeter cube. This was our last value. 10.5, 10.0 was our last value. We do not have any data for 10.5 cm cube. But to find that value, you need to extend this line. You can do in the dotted form like this. All right. Yes, Ishal, is it clear?
Yes.
Now, after extrapolating the line, you need to check at exactly which point you have the 10.5 line intersecting. This is the 10.5. This solid black line is the line of the 10.5 centimeter cube of water. So this is the point where you are getting the answer. I'm not getting the same values again because I'm doing with my hand. You have the skill with you to do on the paper. Now, this is the point where the dotted line and the solid line of 10.5 cm cube are intersecting. Now find the temperature by checking this value on the y-axis. So this is where I get around somewhere around here, this value. So you can simply calculate the boxes here and that will give you the value. If this one is 40, 41, 42 and 43, so this time getting 43 or maybe 41, 42, 43, 42.5. More precisely, you can write 42.5. So that answer will be your, that value will be your answer over here. I'm not getting the same value again, all because of the reason I'm doing with my hand. Is it clear now?
Yes, thank you.
That's clear. No problem. And then the next part, D, solubility in gram per 100 cm water is calculated using the equation shown. Solubility is this mass of solid into 100 divided by volume of the water used. Use this equation to calculate the solubility of the ammonium chloride in experiment 1. You have to use this formula and the values from experiment 1 to find the solubility. So how much mass of the solid was dissolved? It was constant. You can see it was a constant value equivalent to 52.525 gram. So 5.25 gram was used. So that will be the value in the numerator divided by volume of the water used. So in experiment 1, you had used 8 cm cube of the water. So simply calculate the value. It will be, you can either write 65.63. That will be sufficient. That's your answer. Wait a second. We and yeah, we have to multiply that value as well. So multiply the value. Then E part, describe how the solubility of ammonium chloride changes as the temperature changes. So what we learned from the graph, from the table, that as you are adding more and more amount of the water, the temperature is dropping. The mass is constant, temperature is dropping, and you are increasing the volume of the water, distilled water. So what happens, how the solubility of the molecular changes as the temperature changes? Solubility, as mentioned here, it is mass divided by volume. So when you are adding more value, if you are adding more distilled water, it will increase. The value of the water will increase. So as a result, the overall value will decrease. Overall value goes for the solubility. So the solubility will decrease as a temperature increases. You can see from here, we have the increase in the temperature. If the temperature is increasing over here from lower value to higher value, अगर आप इसकी तरह इंक्रीज करते जाते हैं टेम्परेचर को, तो उस टाइम पर वॉल्यूम ऑफ द वाटर इज डिक्रीजिंग, so okay, we can we can say that if the temperature is increasing, टेम्परेचर इंक्रीज कर रहा है, और the volume of distill of H2O वो डिक्रीज कर रही थी, वॉल्यूम ऑफ डिस्टिल वाटर H2O डिक्रीज कर रही थी, क्योंकि हमने देखा 8 cm³ था एट द हाईएस्ट टेम्परेचर। तो यहाँ पे हमने वॉल्यूम ही देखना है सोलिबिलिटी में, द वॉल्यूम ऑफ द H2O। तो अगर हम यहाँ पे मैस, बल्कि इसमें कहते हैं मैस हमारे पास कांस्टेंट है, दिस वैल्यू इज कांस्टेंट, mass is constant, and volume is decreasing by increasing temperature. So what will happen? The whole thing will increase. If the denominator value decreases, then the overall value increases. That shows solubility increases. So you will say by increasing temperature, solubility increases. You have inferred this information from the table. So students, we have done a lot of questions today. We will continue the remaining questions in our next class. So if you have any questions till now, please let me know. And don't forget to get the printout